Hey guys, today we're going to check your Scatterplot's association practice. So remember to put your checks, your X's, and if you had to mark something wrong, please make sure you write the correct answer. All right, so let's get started. Number one, we want to determine whether the scatterplot might show a positive, negative, or no relationship. Number one, number of pages printed by an inkjet printer and the amount of ink left in the cartridge. Well, according to what we've learned, if things travel together, they're positive. If things travel opposite, they're negative. And then common sense will tell us if there's no relationship. So it says, as we print pages, number of pages. So as that goes up, the amount of ink in the ink cartridge goes down because you're using it. And since those travel opposite of each other, for number one, you should have gotten a negative relationship. So remember, check it or change it. Number two, the age of a child and a child's shoe size. Well, typically, as a child gets older, the age goes up, their shoe size gets bigger. It goes up. So since they travel together, that should be a positive relationship. Number three, the number of letters in a person's first name and a person's height. Well, it doesn't matter how many letters you have in your name. That's not going to affect your height. So number three should be no relationship. Now let's look at the graphs for 4 through 6. So just a quick reminder. If something is a strong correlation, the points are close together, they're tight together. Weak means they're spread out a little bit. Positive, remember, is increasing and negative is decreasing. So if you look at 4, those are tight together, so it's going to be strong. So I mark out B and D. And then I notice that my points or dots are decreasing, they're going down. So that is going to be a strong negative correlation. Number 5. So that actually looks to me that is no correlation because it's not positive or negative, so it's going to have to be no correlation. And if it's no correlation, it doesn't matter if it's strong or weak. Look at number 6. So it says, which best describes the relationship between the variables? And by the way, that's the question we're answering for all of these. Which best describes the relationship between the variables? So let's look at 6. First of all, I notice it looks positive. It looks like the dots are increasing. So I'm going to go ahead and get rid of the negative choice and the no correlation choice. And then I notice that the dots are kind of spread out. So that means it's weak. If it were strong, they would be tight, tight, tight together. All right, so now let's take a look at 7 through 10. I'm actually going to go ahead and do 9 and 10 because they're already graphs. And then I'm going to go over the tables. On number 9, those look pretty tight. They're pretty close to each other, so it's going to be a strong. And then the line looks like it's going up. So that's going to be a strong positive. So that's your answer for number 9. And number 10, again, those look like they're going up and they're pretty close together, the dots are. So that's going to be a strong positive. And it's okay if you didn't write strong in, just do that now. Now let's use the graphic calculator, Desmos, to do 7 and 8. So let's focus on 7. So it looks like they're comparing the number of study hours and a person's grade. So we're trying to see if there's a trend or a relationship there. So I'm going to go to Desmos. I want to add a table, and I'm going to put those in. So I've got 384. That's my first person. My second person studied 2 hours and got a 77. My third person studied 5 hours and got a 92. My next person studied 1 hour and got a 70. The next person didn't study at all and got a 60, so 0, 60. Next person studied 4 hours and got a 90 for their grade. And the last person studied 3 hours and got a 75. Now remember, if you can't see your dots, you can shrink or grow your zoom in or zoom out. So I can clearly see that there is a positive. So the lines look, or the dots look like they're increasing from 60 up. And it kind of looks like a strong correlation to me because the dots are pretty close together. So for 7, give yourself a check if you got strong correlation. And if you didn't put strong, go ahead and change that or add it. And last but not least, let's look at number 8. Describe the correlation. So it looks to me like they're comparing the elevation, that's how tall something is or how high up it is, with the average annual temperature. So I'm going to go clear the old table. I'm going to add a table. And now let's put in our data points. So I've got at 1,000 meters up, it's 15 degrees Celsius. At 490 meters up, it is 20 degrees. At 2,200 meters up, 8 degrees. At 650 meters up, the temperature was 17 degrees. See how a table actually represents a situation? At 1,750 meters up, the temperature is 8 degrees. At 1,500 meters up, the temperature is 12.5 degrees. At 800 meters, an elevation of 800 meters, your temperature is 18 degrees. At 1,400, your temperature is 15. At 2,000 degrees, your temperature is 10. And at 1,200 degrees, your temperature is 12. Now, guys, I know I'm going to have to do some moving around, so you can use your mouse. Look at these numbers. There we go. Okay. So look at that. Does there seem to be a relationship there? I don't think so, guys. I can't clearly see. I don't know, it looks a little bit higher in the beginning. It looks like it goes down some. But as far as if I were just looking at that on here, I would say there is no correlation. So let's write for number 8, no correlation. All right, so one more time, make sure that you have checked and corrected everything, and I'll talk to you guys later. Bye.